I'm ready to roll. Okay. Well, thank you all so much for having me. It's really an honor to be here. Uh, I am really looking forward to this. And in some ways, I wish some of this information was around when I was looking for 3D printing. So I always say that I love this cartoon. There are so many people that want to line up for uh, for 3D printing or 3D printers, but there's nobody in line for the design for additive. And that is actually the most important part of the whole thing. The 3D printer is just much like a fax machine or a regular printer. It's going to do exactly what you tell it to do. It's going to print exactly what you say for the most part. But it's the designers, the creative designers, that really make a difference. It's super easy to buy a 3D printer. It's a lot harder to learn to design for additive and learn those manufacturing techniques. And so again, thanks for joining. If you just came in, you're going to see my slides, me in the bottom right-hand corner. One thing that you may want to do is make me in presenter view so you can see the whole screen if you haven't done that already. So let's get started. In 2006, I flew into the jungle of Guatemala to start a prosthetic clinic. And when I say the jungle of Guatemala, I mean the jungle of Guatemala. We're talking mosquitoes the size of hummingbirds, scorpions, critters, all those things. But what's crazy enough, in the weather is just brutal sometimes, hot, humid, dusty, dirty, is the first world applications, the traditional ways that we make prostheses, literally vaporize within months. Liners literally become just the fabric and threads. The gel, the silicone, just for whatever reason in the jungle of Guatemala, just disintegrates. So while we were there that first year, not only did we set up a full lab, but we were able to see 12 people walk. It was an emotional time for me. You know, it was a time that I'll never forget it. Kids walked for the first time, parents walked for the first time. But the reality is, when I saw this, hold on. When I saw the real need, the World Health Organization says that 0.7% of any given population has an amputation, which means that there's 100,000 amputees in Guatemala alone. And this is why this slide is so important. You know, I said that I reached 12 amputees, but I just finished saying that the World Health Organization says there's 100,000 amputees that need our services. And my colleague came to me after I came back from one of these trips, and he says, Brent, you know, I love what you're doing, but it's not good enough. It's not scalable. And that really hit me hard, because I knew that to reach the rest of the amputees, not only in Guatemala, but the rest of the world, we needed something scalable. And that's what's taken me down this 3D printing journey. The funny thing is, once I got back from the trip, he said, hey, Brent, here's what you should do. You should take a cast the way that you've always taken a cast. You scan it, then you scan the outside of the cast, and then you fit the cast. And I was like, man, that is just a terrible idea. Scan the outside of a cast? That doesn't even make sense. But I did it anyway. I went along with it. And I scanned the outside of the cast for a patient. At this time, we were carving. And then I went to fit the patient. And little did I know, I was super, super close. It was amazing. I could not believe it. How is it that I scanned the outside of my cast, reduced the thickness of the cast, and I was still close? And that got me thinking, well, are there some other things that I can do to make it even better? Are there ways that I can take a better cast? And what we did was so exciting because the technology was starting to be put in place. That other slide that I had up was a Polhemus scanner, which has aged very well, but is still very, very expensive. The scanner that you see in front of you that was released in 2014, 2015 has kind of become a staple in our industry called the structure sensor. Now we've got something that's $500 that attaches to an iPad that we can actually scan something. This is fantastic. And I truly think that it's life-changing, world-changing, something that's scalable. The one problem, though, that I realized that was kind of funny was when I tried to incorporate it into my workflow in the jungle of Guatemala, sometimes you'd get a warning like this: unable to connect to the internet. Man, when we're in the jungle of Guatemala, we are just hoping for electricity the whole time. We've got water as long as we have electricity, and internet is a luxury. And most companies are pushing things to the cloud, and we knew that that was not going to be a great option for us. And so that's why we developed an app called DigiScan 3D. DigiScan 3D is available on the App Store. It was never intended to be an app. It was going to be built internally for our nonprofit organization, but so many prosthetists asked for it, we finally did it. The big difference between this app and all the other ones is that it was scratch built, literally from scratch. And so the three things that it does very well: it exports an STL file in the native format. It gives you a very clean scan, and everything stays resident on the iPad. The bonus is that as long as you're in the iOS ecosystem, you're good to go. You can just airdrop your files over. You don't even need an internet connection. So truly a game changer. So one thing that I always get asked, though, is, hey, Brent, how accurate is the structure sensor? And I will always say, you know what, for the O&P industry, it's accurate enough. It's a tool like anything else. You have to learn how to use it. It is kind of susceptible to lighting issues, but it works. And I love to give this example. This gentleman lost his finger in a table saw accident. He actually makes guitars. This is one of the guitars that he made. And when we were down there, he wanted us to make him a finger so he could get back to playing guitar. And so we used DigiScan 3D to create this self-suspending finger. And I want you to watch his finger as I play this video. He's using it. It's just amazing. I love it. You see the smile, and he's using it. Something very simple, but man, if it's accurate enough for a finger, it's definitely going to be accurate enough for a prosthesis. So, but I know we have those that are kind of curious on what is the actual measurements. And I have these two slides here side by side. This was a mold that I scanned. And then so on the one side, we have hand measurements. On the other side, we have the digital measurements. So we've got 375 millimeters on the left side, and you look at the right side, and we've got 375.36 millimeters. Hey, I will take that all day long. So again, it's a tool that needs to be learned how to use, but it can be accurate in the right hands, just like any tools. A lot of people ask me, hey, Brent, what's some next steps? Okay, you've told me about the scanners. How do I actually get rolling? And I would say it's the same information that was given to me, is start digitizing everything, whether it's the outside of your cast, the inside of your cast, your rectified models, your unrectified models. Just start scanning. That truly is the foundation of everything. But I don't want to paint it all as just roses. It's not. It's going to be a slow start. There's going to be a little bit of pain. You know, cash flow is a big issue right now, and learning something new can sometimes hinder cash flow. But once you get going, you're going to hit this kind of wall, this progress, but a wall nonetheless, and you just keep on pushing. And when you start cresting over that plateau and you get your workflow down, it becomes a well-oiled machine. It's definitely worth it, not only for practices that are growing, but it's a way to get your time back as well. But there is a significant investment of time up front. So let's talk about the scan setup. One thing that I always like to mention is a cast. We take a cast. I'm a very hands-on prosthetist. I believe that you try to capture whatever whatever phase of gait the prosthesis needs to be most comfortable in, and you want to try to capture all those shapes at the same time. And so for us, for like a transtibial amputee, we try to simulate weight bearing. And you'll see that we take a cast, and it's a very tight cast, very similar to what Coyote Design does with their RCR, now stable flex socket. But you can see that I use some jigs on the outside, or fixtures, that help me get the interosseous space, medial flat, medial flare, over the medial condyle. And what's crazy about this jig is that it fits a wide range of people. And we're getting this simulated weight bearing, so we don't have to do as much work on the other side. The other thing that you'll notice is right in here, there's some dots. So this is the distal end of the tibia. I also put a pad under the liner over the fibula to give a little bit of room for that area. So those are all things that you have to think about, and you just think about, okay, what's my final product? What would I normally do to rectify that if doing it traditionally? How can I get that in to my cast and modify? So it's very easy. If you want to scan the outside of the cast, you can scan the outside of the cast. The main thing is you want to make sure that no light or scanning gets in through the bottom. So you want to make sure this is flat. So if your cast isn't flat, especially around the top, you can stuff some foam down in there and just let it stand up on its own. And that just keeps artifacts from coming on the inside of the cast. Or we found out this by accident. Well, it was a resident of ours said, hey, we should try scanning the inside of the cast. And for those of you that know Lewis Brown, there he is doing DigiScan 3D on the bucket. And here it is. We get a great shape capture on the inside of the cast. And literally, it's just a bucket from Home Depot. We have some casting stockinette here, and then the cast gets put down the middle here. It's a great way to capture the inside of the cast, and we found it to be very accurate. So we've covered scanning. Now I know you're going to be wanting to do something other than just scanning, which is why we have to talk about the wall thickness and strengths of sockets. So one of the things that you've got to remember is that there's two main styles of printing, and the type of printing mostly that we're going to talk about today is FDM printing, or kind of the hot glue gun style printing, the one that you see on TV where it builds layer by layer. And if you're going, you've got really two avenues there. If you're going to go just a test socket, but you're not going to be weight bearing through it, you're just checking a fit, you can do something in the 2 to 3 millimeter range for wall thickness. But if you're actually going to put a patient on this and either send them out or you're going to have them walk on it, my suggestion is somewhere between the 4 and 5 millimeter range. And the other part is you do not want to have any infill. You want these sockets to be solid. The problem with infill is that you have a little bit of space, and if there's some movement, it can start some kind of micro cracking, and then you end up with just catastrophic cracking. So no infill. The next thing that you want to do is figure out, okay, so I know what I'm going to do is now I'm going to choose my design software. I started off using Autodesk Mesh Mixer and Autodesk Fusion 360. Mesh Mixer is fantastic. It's free. That is a fantastic price, especially for thrifty prosthetists. Fusion 360, very inexpensive, sub $500. The problem with these systems, though, is that I found, especially when trying to incorporate my work with the developing world as well, is that connection to the internet. If I don't have a connection to the internet, I'm not able to use Fusion 360. And this became very apparent when we had a hurricane pass through when we were in Guatemala, and it knocked down all our power, internet, and everything. And I would have been dead in the water if it hadn't been for a trial license of Freeform, which we're going to go over very shortly. But it's a great way to start. It's a great way to get the workflow going. This is a very interesting differentiation between most modeling programs and the modeling program that I'm getting ready to show you. The modeling program that I just showed you, the Mesh Mixer and Fusion 360, uses a mesh style construction. So this is on the right here. You can see it's made up of a bunch of triangles, and these triangles are then scaled. The demo that I'm getting ready to do is a demo with Freeform or Freeform Plus, and it's a voxel-based program. And the idea is that these cubes make up a volume, and you can size these cubes in different sizes. This makes for very, very precise movements. Whereas the other way, you're stretching triangles, reducing triangles, you're actually pushing these blocks out of the way or adding blocks. So it's a more true thing, a way to do what we typically do, which is in plaster and building or clay models, essentially. So let's hop into a demo of Freeform. All right. So we have Freeform here. And what's neat about Freeform, as I'm moving this around, is there's something called a haptic device. And I'm going to show you what this looks like live. So a haptic device allows you to move your model around in really six axes. So here I am just moving my model around. It is really kind of neat to see. And then I'm going to leave that up while I'm modifying this. But one of the neat things is this gives you feedback when you touch your model. So I call it my digital Sureform. It's just really, really neat. And it also then gives you a lot of opportunity to do some other things within the program that you would not be able to do with a mouse. So what I'm going to do is put that in the bottom right-hand corner, and then I will do most of my work over here so you can kind of see what I'm doing. So the first thing that we have done, you can kind of see when I pull this up nice and close, is that these are all triangles. And what we're going to do is we're going to convert that into a voxel-based model. So we're going to just press apply. So here we are. We've got our voxel-based model, and you can see how it's everything is smoothed out really nice here. So the next thing that we're going to do is we're going to go ahead and just smooth this. So we're just going to do almost like a little bit of sand screen. We're just going to smooth it just a little bit, and you can kind of see how this changed to kind of a shiny look right here. And that's exactly what we want. So we're good to go there. And now we're going to make the actual model that we're going to put the trim lines on. So here we go. And I know we've got a bunch of prosthesis on here, but you're just going to have to bear with me just for the sake of time. These trim lines are not going to be perfect, but here we go. So I'm putting these trim lines on. Perfect. Oh, that's going to bug me. So let's just move this a little bit. All right. And now we're going to make the socket. And we're going to say, we're going to go 4 millimeters on this one. So here's your 4 millimeters right here. I'm going to say apply. So there's our socket. Now we have our socket, but we don't have anything for this coyote lock to drop into. So what I'm going to do is I have this tooling, and I'm going to say, you know what? I want to combine that into, my final mesh. And there it goes. And you know what? I'm not a big fan of that transition right here. So I'm just going to quickly smooth this up here and just make it a little bit smoother. You don't have to, just what it looks like. All right, we're actually almost all the way there. Now we're going to bust out that first model. So we say Boolean remove from, and we've got our socket, but we don't have the hole already for the locking mechanism to drop into, but we do have a tool for that. So we have this cylinder. So we're going to Boolean remove from that mesh clay. And there we are. We've got the locking mechanism, the hole, the socket. It's ready to send to our printer for 3D printing. And that's really the power of freeform. You know, I talked through all this. And so it just took like maybe 4 minutes, 5 minutes, something like that. But everything goes really, really quickly when you're able to concentrate on it all the way. So this is Freeform or Freeform Plus. You can buy it from a reseller. I, with Additive America, we are resellers of Freeform, and we also train in it as well. So let's get back to the presentation. I always put a little slide in here just in case something doesn't go right. So we're going to go on to the next one. And here we go. Okay. A lot of people say, okay, Brent, you're doing some 3D printing, and but what kind of numbers are you getting? What kind of testing? And I tell you, we take this testing very, very serious. Obviously, we have patients that are going to be wearing this, and it could be an issue. And so we actually hired an outside firm to test all our designs, to give us the good and the bad news. And so here on the left side, you see one of our testing apparatuses. And what you've got is you've got a vertical force at a 20-degree angle And what that does is simulate that weight bearing when the socket is going to be taking the most pressure. What we found is these sockets are actually very, very strong. In fact, so strong, you look on the right side here, that we broke a lot of components, tube clamps, a feet, and all that. So testing is important. One of the neat things is, for some of our definitive sockets, we actually had those tested and they did not fail catastrophically. This mandrel actually slid out of the socket. So the socket deformed enough and failed. And it was around the 3,000 pound mark and let the mandrel out. So the test had to be stopped. So that is one of the reasons why we're very excited about the way that we do our definitive sockets. Now, we've said the good, but we haven't talked about the bad a lot. There's a learning curve that goes on. So this was a AFO that I did. It's been actually a few years now. A totally wrong design, wrong material. I did it anyway, but it failed. I had it on a friend of mine that wanted to do something 3D printed, and about 10 steps in, it broke. Everybody has 3D printed things that fail. This one up here in the corner is the one that hurt me the most, because this was in the jungle of Guatemala. We only have a certain amount of time that we're printing there. And if we have something go bad, we've got to either start over or we have to put one item kind of on the back burner as we go through the other things. And then this bottom one is the bird's nest. This one is always the funniest one, because those that 3D print know this feeling. You put something on the printer, and a couple hours later, you think that you're going to go up and see just something awesome, and you end up with this bird's nest. It's just not awesome. But I want to share with you, so that's some of the bad, but I want to share with you some of the things that are really the touching stories that got me into 3D printing. It is the life change that I've seen from 3D printed devices, specifically in Guatemala and specifically for upper extremity prostheses. Veronica, who you see on the left, came to us roughly about 5 years ago, and she wouldn't even look us in the eye. She had masked men came into her house and with machetes, and literally they killed her father with the machete, and she was able to get away, but they took her arm with machete, and you can see that she has scarring on her other extremities and some on her face as well. So this 20-year-old young lady, her life turned upside down. She came to us and she wanted an arm to feel whole or complete. And at that time, we weren't really doing upper extremity prostheses because just the components are so expensive. But it was just right at the time that I was starting. So I said, I think I can do something for you. So we printed her 3D printing prosthesis, put it on, and it was like just a switch went off in her face. The smile came back, and now years later, here she is with us at every single clinic, helping patients, guiding them through the process, encouraging them along the way. She's actually gotten involved in the community with people with disabilities, amputations, and such. It truly was a life change, something that could only be done with 3D printing. Incredible. And you know what? I only had about $15 in materials. It's far less than the $1,000 that I would have had in it if I traditionally manufactured it. It's the power of 3D printing. It couldn't be done any other way. This is a fun little slide. We've got a guy that wanted to ride a motorcycle and a bicycle. So we created this little Lego hand for him. And then this young girl in the middle, we kind of got her a starter prosthesis rolling. And on the right side, you see my one of the printers that runs and makes these devices. Pretty pretty neat to see this happening in the jungle of Guatemala. And for those of you that have four-legged friends, I know Ben talked earlier about four-legged friends. This was Haley that came. She was born without her paw, 7 months old, and the owners realized that she was having some shoulder subluxation. So we were able to create a 3D printed prosthesis for her. This prosthesis, probably 10 bucks of material, weighs, I believe it was around 100 grams, something that couldn't be done traditionally fabricated. And here she is.
I think we're good to go. I like it for this adjustment anyway.
It's very cool to see.
We'll see how that
Something
back
that
shell
couldn't be
holds up.
done traditionally.
I'm going to go ahead and attach it to that, that strap that's coming off the back.
All right.
So that's Haley. Let's talk about Christopher. You know, we talk about value add things all the time. I've been seeing Christopher for a long time for his AFOs. Christopher has CP. And it turns out that none of the wheelchair manufacturers make something that allows for deep or tall cups. It just doesn't happen. And so I said, well, I think I can 3D print something like that for you guys. I just took some quick dimensions. I probably had a half an hour in design, $3-4 in material. And we printed this. This cup holder has been all over the world, literally all over the world. And they can't believe it. But you know what? Do I have a patient for life now? I didn't charge them for that. But when somebody asks, well, where did you get that cup holder? Or who does your braces? Do you think it's going to be somebody that it's going to be me? It's going to be, hey, not only did Brent do my braces, but he also took care of us. We did this cup holder and such. It's just a very neat thing. And then this is actually one of my favorite stories, not my most favorite story, but this is a favorite story of mine. This young girl was born with some mental issues, and the doctor really didn't even think that she was going to make it, but she started kind of turning the corner, and the doctor said, you know what, we're going to give her a prosthesis, but it's only going to be for her to stand. And so we did this prosthesis, and the therapist called a few weeks later and says, hey, Brent, she's like dragging the prosthesis all around, and we need to get something that's lighter and she can walk with. And so we created this exoskeletal prosthesis with some knee stability for her. This whole prosthesis weighed under 300 grams. It was incredible. And here she is, kind of off to the races. This is the first day. And I just love this. And she started doing better and better. And the therapist loved it. It's something that cannot be done with traditional fabrication. This is very interesting. This is Penny. Penny actually works with us. She's a podorthist. She has a diagnosis of MS. And she came to me and she says, Brent, I really want to change away from my traditional brace. I want you to do something 3D printed. I said, okay. And she said, but here's the kicker. I'm going to wear sandals and I'm not going to wear socks. And I said, Penny, you know, that's the discussion that we have with our patients. You know, you're going to wear socks and you're going to wear shoes. She goes, I know, but this is what I want. And so here Penny is talking about her brace. All righty. Well, Penny, you've had this on for a few minutes here. What do you think of this AFO?
I love it. It's phenomenal. I feel like I have no weight on me at all. It's just
one of the neat
giving me
things
lots of feedback
that
every
Penny
time I
did,
step.
calling me when she's finished talking.
I feel like I have support, even in my leg and my knee. I'm not hyperextended. It's phenomenal.
Typical noises in the lab, right? Cool. So one of the neat things is Penny called me just a couple weeks after this, and she said, Brent, I was raking the leaves in my daughter-in-law's yard, and I didn't realize how long it had been. I would have never been able to do that in my other brace. And so here we are, this lady that works with us wanted to wear sandals, no socks, and have a short brace, all the things that they tell us not to do in school, and seemingly it worked. And I can tell you even, so this was probably about 1.5 years ago, she is still going strong with a 3D printed brace. This is an interesting case. This was Clyde. She's in Guatemala, and she was born without both of her arms below her elbow. And so on her right side, we created this kind of pop-on device for her that allows to hold multiple terminal devices or multiple things like spoons, forks, and such. Here she is, 13 years old. All she wanted to do was be able to feed herself, put makeup on, do her hair, and here she is doing all of it. So, and on the left side, you can see that we've done a Victoria hand project, a figure of 9 harness, and a regular style below elbow suspension. But it was really a neat thing to see. Something that we couldn't have done with traditional fabrication, at least cost effectively. And so a lot of people say, well, what about active people, Brent? You've shown me some people that have the upper extremity amputations. You've shown me some lower stuff. How about some runners or something? So let's show you this. This is Faisal, and he's a beast. And he's running on a very open frame 3D printed socket. Super strong. And you can see he's putting plenty of power to it. Neat. I love this story, and I'm going to go ahead and play his story. Ben is a bilateral amputee, was in a terrible motorcycle accident. He was NYPD, and this was him wearing a 3D printed socket for the first time. It's pretty neat. And about the socket so far?
I am thinking that it is
Oh, it's locking up.
the lightest that I've had in 16 years. Extremely comfortable. It was, stepped right into it. It was a perfect fit from the get-go. The weight, I can't explain. The weight is, you get to really small amounts in pounds, you start breaking it down. The weight is second to none, literally, good expression, second to none. I can skip, I just skipped. I haven't skipped in a long time. So, she'll skip. I can jump.
So this was crazy. You know, here he is, missing one arm and one leg, and he is just putting all kinds of pressure through the prosthesis. You know, you kind of hold your breath, but he's doing fine. In fact, I think we have an activity tracker on him. I'll have to talk to the clinician, but he's had over 3-4 million steps on his prosthesis without issues. Very, very neat thing. And about the size. And then this is probably one of my, this is my favorite story. It really shows the power of what 3D printing does. This young lady came to me. She had gone to another facility, and she's a long Symes, and they had done all kinds of like shells and all kinds of stuff, and it was just this big chunky prosthesis. And you can see she's a very petite young lady. And young ladies at this age love their style and form-fitting clothes and such. And she said, Brent, I just want something that I can wear you know, my tighter jeans, my yoga pants or leggings or whatever they're called. Can you help me? And so what we did is we created this Symes prosthesis that had flex zones so she could push through, almost like an old-timey socket, a stovepipe socket, but it was 3D printed. And some of these areas of the 3D print got close to 1 millimeter thick. So her prosthesis in total, including the foot, weighed 1 pound. And so here's what she had to say about it. She's super excited. Yeah. Go ahead.
All right. So when I first saw the leg, I was a little skeptical if it was gonna fit for the first time out. But when I put it on, it felt really comfortable, and my leg just slipped through, but it still like held on comfortably.
Mm-hmm.
And so like, and then I went on for a walk, which when I walked, it gave it a nice bounce, and it made it so much easier to run. And I really like the way my leg feels in
First
it,
time that she'd ever
and
run.
especially the lightness of it compared to my other leg. It's kind of, my other leg is heavier, exceptionally,
Testament to the All-Pro
but
foot,
this
too.
one is so like
Loved it.
feather-like, amazing. I really like this look. It's so comfortable inside, and it's so much fun to just bounce in.
Awesome. So those are all my stories. I just hope that I've inspired you at least to take a look at 3D printing. I was one of the prosthetists that was stuck in my ways. I'm telling you, I thought that anybody that was 3D printing, direct scanning, you know, any of that, I thought they were out of their mind. And I can tell you, after being in this for the last almost 6 years now, it's truly life-changing, and I wouldn't change it for the world. If you want to know more about my nonprofit organization, it's called LifeNabled. If you want to know more about our contract manufacturing company, it's called Additive America. If you want to get up with me, just follow me on LinkedIn. I'd love to connect with you. Do not send me an email, please. I do not check my emails. And Elizabeth can testify to that. She got up with me.
I we're just trying to fight my mouse to get on here. Be like, no, LinkedIn. Don't even bother with the email.
Yeah, so I am quite responsive on LinkedIn. So I look forward to connecting with whoever. And, you know, I'm here for you if you want to really start looking into 3D printing. The biggest thing is it's important to start and to be willing to take the time. And, you know, we've made a lot of mistakes along the way, and there's no need to blaze the trail again. Learn from us, learn from other people. There's other people that I'm cheering along on LinkedIn as well that are doing very similar things as us. So again, thank you for your time. Thank you for inviting me in. I've really enjoyed this. It's definitely interesting with the videos and all this stuff going on, but it has been awesome. So I've left a few minutes for questions. I'm happy to take any questions, and then we can also talk offline on LinkedIn if you would like.
Brent, that was an excellent talk and amazing humanitarian work that you're doing, and combining your talent and your expertise and your passion. What a phenomenal thing. Proud to hear it. But my question was, that looked like an awful short Symes. I've never seen a foot like that fit under a Symes ankle disarticulation. So is that truly a Symes there?
It sure is. Her femur is about this long.
Oh, okay.
So it's PFFD.
Okay.
I
was going to say, you're an awful lucky guy to have one like that, to be able to have that length for that foot underneath there.
What's crazy is I put one of the All-Pro posterior mount foot on, and I had to move the mount all the way to the bottom almost, because I couldn't cut any off. I didn't cut any off. I left it full length. But I'm telling you, it was an awesome foot, and she loved it.
And let me ask you this, that socket that you said that you constructed that she could, flex somewhat to get into, what's that the consistency of? I mean, and do you get a rigidity in one place and flexibility because you make it so thin so she can punch through it?
That's right. Yeah. So you make it thin to punch through it, like the old stove type
the bladder
loss.
mechanism.
Yeah, that sort of thing. Except you don't have to have the mechanism on the outside. One thing that I'm not super proud of on this case is I didn't realize that I was going to have suction.
Oh, wow.
So she slipped in and couldn't get out.
Oh my God, who would have thought that? Way to go there.
Oh my goodness, that was yeah.
What a great job. And isn't the owner of your company Paul Suggs?
Yeah,
right?
yeah.
I went to Northwestern with Paul for orthotics in 1989, dude. And
oh wow,
Paul was a heck of a guy and creative as can be. And I can see he promotes that in your company. And what a great job. Please tell him Roger Marzano said hello to him. And I relish the days being with him. But what a great talk. I can't believe I learned a lot today, and you rocked it.
Oh, well, thanks so much.
Don't forget to tell everybody about your talk tomorrow.
Oh, yes, thank you. So I do have a talk tomorrow. It is how to choose a 3D printer. So not only do I go through some of the steps, anatomies of a 3D printer for test sockets, we also get to talk to Jackie Bailey from East Point in Ohio. And so it is awesome. She is an amazing prosthetist, and she is actually a pioneer in the model that we have, which is mobile and digital, and we have a brick and mortar there in Ohio. But it is, I think it's something worth watching. I'm excited to share it, and I think we'll get a lot from it as well. But so that's tomorrow, I believe at 11. Is that right? I think so.
Yeah, yep, that sounds right. So tomorrow we're running 3 tracks concurrently: prosthetics, orthotics, pedorthics, and we also have a section that is, I put it in general sessions because it's a Spanish for O&P live panel with Chad Duncan from Northwestern and some of his either former students from Alabama State or current students from Northwestern or other people that are bilingual. And so that one's going to be in the general sessions in the afternoon. And I think John Brinkman's doing ethics and healthcare disparities in the general sessions, but the mornings are all separate: prosthetics, orthotics, and pedorthics. And you're in the prosthetics section, which if everybody just goes to March 13th on the schedule, they'll be able to see what the whole schedule is for tomorrow. So yeah, it's going to be amazing.
Can I ask one more question of Brent?
Yeah, sure.
That AFO that you constructed for your pedorthis there, what consistency was that plastic? If you were to give me something to compare it to, like a copolymer type?
Yeah, so that's the way that, so it's a nylon 12, but you know, I always say, listen, I am a mountain boy from North Carolina. So if I can do 3D printing, you can do 3D printing. And so the way that I learned from an orthotist that had been doing, you know, building orthoses for 40 plus years. And he taught me how to tune copolymer braces for walking. And so I've kind of taken that knowledge, I guess, and put it into the way that you do 3D printing. So you'll notice that the strut is away. You know, we have flat, kind of a curved surface there. I did split the strut. She liked it a lot. What we did is about a year into it, we did have a strut fail just on one side. And so with that, because of some of the new software and such, I was able to put the strut into a software to show where things flex and such. And I actually had the software design a strut for me. So that strut that you saw has evolved to a different shape that was generated by the computer that I would have never thought of. So
and there was a different independent unit to the calf cuff and the foot plate.
Yeah, that's a whole nother. So what we're trying to do is get people to scan.
Right.
Scan and either send off or what have you. But it's not far behind. Like when we do our definitive prostheses for our patients, all that stuff, you saw the testing apparatus, so that's been done there. But it's also been, we have our own print, or not printed, but machine parts that go into the print that have been engineered specifically for it. And then we've done the FEA analysis on it. So all our prostheses go out the door with that specific distal end on it, which means that it's going to be strong enough, because that's where the failures always are. Like even in laminations or copolymer sockets, it's always around
Right.
forces of the distal end.
Well, it's just like when you went and smoothed that edge where that shuttle will attach to the socket. That radius you created increased the strength exponentially. So
Yeah,
that's the stuff you can do that you can't do when you're molding plastic and even
right.
creating the lamination. So great job. I don't want to occupy your time. I'll be looking forward to hearing Jackie tomorrow. Just wanted to say, great talk.
Great. And I'm available for more questions if anybody else wants to ask.
Yeah, this is your room and you're the last one, so you can, anybody that wants to turn their camera on and talk directly can go right ahead. I'm going to put Jerry Stark's technical readiness tomorrow at 3 o'clock opposite the healthcare ethics and healthcare disparities, because I think I know it's a little bit short. So that would be at the end of the day tomorrow. So if anybody wants to see Jerry live tomorrow, that's when it will be.
Great job today, Elizabeth. This was awesome.
Oh, yeah, amazing job.
Thanks,
Yeah,
Roger.
that's a.
It's it'll be even better tomorrow.
Good.
I'm going to start working on my hair right now.
And Brent, your presentation style, I love the background and you being able to talk and interact like that. Very creative.
Oh, well, thank you so much.
Pleasure to
Yeah.
meet you.
Yep.
Right. So the Brent survey link is in the chat. If anybody missed any of the other links, just send me an email or a text message, and I will see you tomorrow morning at 9 o'clock. Thanks, Brent. That was awesome.
Hey, thanks so much. Thanks for the invite.
You're welcome.